Hello and welcome to another video in the network automation series. Here we are going to implement 3 routers in 3 locations using zero-touch provisioning, meaning without loading any configurations in it. The router while booting up will fetch its configuration from a TFTP server with the help of a DHCP server. Here we have a lab setup with a core layer and a branch layer. Then we have a TFTP server. This server stores and provides the configuration for the branch routers if the branch routers request for the right file. In this session, let's see how we can force a newly booting router to request for its configuration file from the TFTP server. Remember, the TFTP server has a list of files in it and we have to request with the correct file name to get the right file. The zero-touch deployment process starts with the branch router's DHCP request to the DHCP server. Here we have the DHCP server configured in one of the core router. As you can see, every branch router is connected to the core router with a /30 IP address. This /30 subnet is the DHCP IP pool for that branch. /30 subnet has only 2 usable IP addresses, and if we configure the first available IP to the core side of the link, the new router is forced to take the second IP in the pool. And that's how we can predict the interface IP of the new router. Now let's have a look at the DHCP pools. Each branch router has a /30 IP pool and the IP address of the TFTP server with the option 150. In this example, only the New York IP pool got an additional line with the option 67, and that is to specify the config file name directly from the DHCP pool. For the other 2 branches, London and Japan, we'll be utilizing another mechanism using network-config file. If we don't specify a specific config file in the DHCP pool, upon getting the IP address and the TFTP IP from the DHCP server, a Cisco router will look for the network config file in the TFTP server by default. The network config file is a mapping of hostname to the IP address. The router will look for its own IP in the network config file and choose its hostname. After that, the router assumes its config file name by appending -config to its hostname. In this example, since the hostname is London, the config file name should be london-config. But please note, the config file name should be in small case, regardless if there is capitals in the hostname. Now let's have a look at the TFTP server's root folder. And let's make sure all the branch routers expected config file names are available in the TFTP server. So let's take a quick look at the config files contents. How to auto-generate the config files for the routers will be covered in a future video. For now, let's have some manual contents just to verify the zero-touch operations. I kept unique host names and few additional contents in the file just to prove the concept. Now let's see these things in action. After booting the branch routers, you can see the London router initially went looking for the network config file and learned about its host name from the file, and again went back to the TFTP server looking for its specific configuration file, which is the london-config, and then loaded from it. But in the New York router's case, we provided the config file name directly. So instead of looking for the network config file, it went for the New York direct config, which is the file name we provided with the option 67, and loaded directly from it. So that's how you can do the zero-touch provisioning with zero codes just by using a TFTP server and a DHCP server. Thank you very much for listening to this. Please subscribe the channel for more similar contents. In the next video, we will see how we can validate a router's hardware before onboarding it to the network.